All right, so, hey, I'm on page 5. I know that you may have done your stem and leaf plot on page 5 as just not a split stem. You might have done yours with just the 5, 6, 7, 8, and 9, okay? And if that's the case, then yours would look a little bit different than mine. But do make sure that you included a key. So if I had 53, and that was 53 points, because these were the points scored by the basketball team during the season. All right, number 2, the one that corresponded with that was G. And then number 3, so let's talk about that number 3. When I had talked to you about doing a dot plot, I had guided you into this format over here on the right, because that really is gearing you towards doing a histogram, okay? So I looked back up dot plot specifically because I was afraid this might just be the dot method for making a histogram, and that is true. Technically, your dot plots by name should be a number, a dot for each specific piece of data. So technically, your dot plot should show you each specific piece of data, not the range. Okay? So I wanted to correct that since I had indicated the way that we did this histogram. Okay? So whichever ways you had done on that, do make sure that you, each specific piece of data, so do make sure that you label that. All right. Then number 4 was G and number 5 was A. Okay, so let's go on to page 8. And then on this page, I'm also going to be showing you a way of doing standard deviation on the calculator. So here, the first problem, the mean, this is just can you calculate? The mean was 130.38 and the median was 133. Now, when we get to number 2, this is where it gets interesting, because what can you say about that value, 244, compared to the rest of the data? Is it like the rest of the data or different? It's very different. It's probably an outlier if we did the computing. So, when the outlier was in there, our mean was 192.57 and our median was 189. Okay, look what happened whenever you took away that outlier and made it more like the rest of the data. Then what happened to our mean? It changed. So our mean changed and our median did not. So that's a very important concept that I need you to have in your mind, is that the median is resistant to outliers. Median is resistant to outliers, which means that it was not changed or affected by the outliers, okay? And whereas the mean is affected. So if you have an outlier, a better representation of the center of the data is median. So if you have skew, which we'll talk about in a minute, or if you have outliers, median is the better choice to go with than mean. Okay, the next one, calculate the trimmed mean. Well, that one is just showing that if you eliminate the smallest and the largest, that's what the trimmed mean is. So it's kind of taking out any outliers if there happens to be any. So that ends up making these closer together because you've kind of eliminated any way whacked out data. All right, and then this last one, number 3 on this page, make sure you did a key. See if you forgot that, because that tends to be something that we forget. Make sure you did a key on the last one. All right. It asked you to do a split stem plot, so that's why you had 2, 2, 3, 3, 4, 4. And then the mean was 35.3, the median 35.5, Q1 was 29, Q3 was 42. Okay. All right. So, there was that page. All right. The next one, we did the standard deviation by hand. And so let's kind of talk through that. So, by definition, what is the standard deviation? That's a big concept we learned yesterday. Standard deviation is the what? Not just distance from the mean, but the average. So if you take all the data and you average those distances, that's the standard deviation. Standard deviation, average distance. Okay, so whenever we put this 44 in here, what do you think that's going to do to the average distance from the mean? It's an outlier, so it's going to make that average distance go up. So let's see what happened. What's the first thing in the process that you do? What is this step here doing? Subtracting the mean to figure out what? The deviation, which is how far each piece of data is from the mean. So that's what we found first. Now, by rule, what do all of the deviations add to be? 0. Okay, so all of those added to 0, which does nothing for us in terms of finding an average. So that we don't have that situation happening, what do you do to alleviate that problem? You square them. So that was them squared. Then we summed it with the capital sigma summation divided by n minus 1, and that gives a variance of 105.87. Then how's the variance related to the standard deviation? You got to do what to the variance? Square root it. So square root the variance and you get the standard deviation. So do you see how this 10.29 is much bigger than the previous 2.88? It's much more varied because of the 44 in there. Yes, ma'am?
Okay, when it says n minus 1, so when we talk time, we divided by 4.
Okay, yeah. So now, this I have wrong answers on. So by the way, this one's 10.75 and something else there, and that was wrong too. Okay, but you know what I actually want to do is I want to talk to you about how to do these two in the calculator now. So you get to get your calculator out, and I'll write down those steps, and then I'll show them to you on the computer. So you're going to go Stat Edit, and you're going to put your data into list 1. So that's the first thing we're going to do. We're going to put number 5's data, 150, 170, 120, 120, and 90 into the calculator. Okay, so after you have that data in there, then you were going where you had this 5-number summary again, and you were doing the stat, calc, one variable stats. Okay, and remember what was the X bar? What's the X bar stand for? The mean of X. Okay, what were we looking for standard deviation? What symbol on there was on the menu? Good, you were looking for the S with the little x. That's the standard deviation on your calculator that you are looking for. Okay, so there you go. That was your homework on that. Let's now go over to page 14 and 15 and take a look at those. X bar is the mean of the data. All right, now, a couple things on this. Is it true that you could have the same data as me and we could make histograms that look different from each other? Yes. Okay. For one thing, I happen to make each one of my bars too wide, and I don't know why I did that. Okay. Oh, it's still on that. Okay. Thank you. And so, let's see here. Again, yours could look different than mine. So mine has my bars were too wide on that one. And so take a look over here on the right-hand side. What this little chart was for was just to allow you to organize your data. So you may not have even needed this. It allowed you to make your bins and then come up here and look and see how many items were in that range. Okay, so you probably just made a couple dots or whatever and did yours that way. Now, here's some of the questions I got that are mistakes that you may have made. I want to make sure you did not. Number 1, you cannot just put railroad tracks and then put the outlier. Okay? So you can't just say, ooh, that outlier is way out there, so I'm just going to put railroad tracks. No. You can railroad track the front, but then after that, it has to be drawn to scale. So do not go and railroad track the next part because you think that it's going to be, it's too far out there. Okay. The other thing that you cannot do is you cannot make your bins different amounts of size of data. For example, each one of my bins was 10 wide. Then I cannot make this bin right here from 110 to 180. So I can't decide to make this bin go from 110 to 180 because then that has a whole bunch more possible data in it. Okay? You would be violating the area principle. It has to be drawn to scale. All right, so there's that. Do make sure that you also have frequency on the left. Okay, remember how we're paying attention to the different kinds? This one should have frequency on the left. All right, now let's go to the bottom. This bottom one allowed you to do the accumulation. So 2 plus 1 gave you 3, and 3 plus 3 is how you got the accumulation of 6, and so on. And so here is the graph for that. Notice on the left you need cumulative frequency. Cumulative frequency, or that would be wrong. Okay, so make sure the left had that. Now, I want to know why, what's going on that this is flat and not changing right there. Why is that not changing? Go ahead.
No metals, you didn't get any metals already?
Good. You did not add any additional data in that section. So there was no additional data accumulated in this section. That corresponds with this part up here where there was no data. So this being flat corresponds with that. So that was no change. So think of this as showing you change. That's kind of a calculus idea when you're talking about how much change you see. Here we can see that these two sections had the biggest rate of change, the biggest increase in data there. Okay, so there you go. That's that. Moving on to the next one. Next page. All right, so of course on this page, this top one, you can just add up all of those you put how many is on each one of those bars, and I got 182. But I want to make sure you know how to do statement or question B. All right, let's everybody make sure you know how to do this question B. Now, with there being 182 people, how would you find a median? What would you do with those 182 people's ages? Okay, line them all up from least to greatest and then find the middle, okay, which is divided by 2, and that's what I did here. If I split 182 in half, then I've got 91 on the left and 91 on the right, and the median age is right there in the center. So technically, the person that is between, or the age that is between the 91st and the 92nd person, that is the median. Questions there? So that's step number 1 to be able to do that problem. Okay, then you got to go over to the graph and find where that person is located. So I'm looking for the location between the 91st and the 92nd person. So I'm going to come over here, and I see there's 5 people in this first section and 60 people. So I'm up to 65 people. So I'm going to keep going until I find the 91st and the 92nd person, okay? And they're somewhere in that bar. So they are somewhere in that bar, but I still cannot tell their specific age. Because could this bar be filled with 55 10-year-olds? Yes. Could it be filled with 55 14-year-olds? Yes. So I do not know what's in this bar exactly. I just know that my median person is between 10 and up to 15, 10 up to 15 years old. So that is why it has to be an estimate, and I can't give the exact amount. I just know they're in that bar. Okay, questions on that? Because that's an important thing that you need to be able to work through. Okay, and then the other questions were just about that. What kind of movie might that be for children or teens? And then explained how I did that, and I just talked about being between the 91st and 92nd. Okay, next, this picture is somewhat symmetric. This, what would you estimate the mean to be? I mean, because it's symmetric, it's probably going to be somewhere in here. Did somebody put somewhere around 17.5-ish? You know, we're actually going to talk about that relationship between the mean and the median today. And then C, how many cars get between 25 and 15, or 25 and 30, that's 15. Okay, part D, how would I turn this amount of cars, how would I turn 35 cars into a percent? Yeah, I need to divide it by the total amount of cars, which there were 110. So that 35 over 110 is how I got that. All right, that was all. Page 8, 9, 14, and 15. Okay, so now